We are ready now to take a look at how the nervous system is involved in our emotions. And we're going to start off by looking at these neurons called mirror neurons. They're called mirror neurons because they mirror brain activity in our brains while someone else is doing something. So it kind of allows our nervous system to experience something that another individual might be experiencing. So mirror neurons respond while a person is observing someone else do a specific act. A lot of the studies on mirror neurons involve the motor cortex. They are going to be looking at how the motor cortex is becoming active with these mirror neurons when we watch someone else move in a particular way or make a particular motion. So they also respond while performing the same act yourself. So again, that's how it allows us to kind of relate and feel what someone else might be feeling, because it's the same neural activity that we would experience if we were the ones doing the act. They create brain activity just by looking at someone else. So an early example of this would be if you see someone carrying a whole bunch of heavy boxes. And you can relate to that, and you can imagine what it might be like and how they might want to have you lend a hand. That's an example of mirror neurons. Or if you've ever seen someone hit their thumb while they were hammering, and you kind of wince along with them, and it almost hurts you as well. And you can relate to that, again, because when you see them hit their finger with the hammer, it can create a similar sort of emotional reaction in us through these mirror neurons. The degree of mirror neuron activation is related to a person's empathy, so there's a positive correlation there. And in autistic children with delayed mimicry of others, we find that there's lower empathy. So the ability to mimic others and sort of mirror what someone else is doing is also associated with empathy. Now your textbook has this really interesting study looking at class differences in reactions to other people. It's on page 215, and it's in this little box called In the News. And it's a fascinating study, and it found that people with higher socioeconomic status, so basically more income, they pay less attention to other people. They look at others' faces less, and they show less interest in others. And they also have less mirror neuron activity in the motor cortex in response to the hand movements that another person might make. So some really interesting findings here. And the thought questions are, what are some real world implications of these findings, right? That maybe some of the people who we elect or who run corporations might have a harder time empathizing with others. And I'm sure there are other, implications as well, especially, you can think about healthcare and education and so on. So anyways, do take a look at this study. It's really interesting. Now let's look at the autonomic nervous system. Why? Because it's going to be creating a lot of the physiological reactions within us when we're feeling emotion, but it's also going to add to our experience of emotion, because remember, what we feel in terms of emotion is also influenced by what our body is doing, our facial expression, but also what our body is doing in terms of our autonomic nervous system, our heart rate, our respiratory rate. Do we have a dry mouth? Do we have goosebumps? Is our mouth salivating or not, right? Is our mouth dry? Are our palms kind of sweaty? All of those things. So we will be referring to this a lot. And remember, there are two branches of the autonomic nervous system, the sympathetic and the parasympathetic. The sympathetic is that stress system, the fight or flight system that's going to increase arousal and help us prepare for any kind of crisis that might come our way. The parasympathetic is the one that kicks in when everything is fine, everything is relaxed, and there's no urgency. And so just take a moment and look at the reactions in these different parts of our body that we would see if the sympathetic nervous system takes charge versus if the parasympathetic nervous system takes charge here on the right. So heart rate is increased by the sympathetic nervous system, but decreased by the parasympathetic. So sympathetic increases, parasympathetic decreases the heart rate. Digestion is inhibited by the sympathetic nervous system, because if there's an emergency, now's not the time to be working on digestion, right? Palms might get a little sweaty. There's actually some research showing that a little bit of moisture on your hands help you grip things, objects better. And so if you had to grip something, hang on to something, a little bit of moisture on your hands is actually a benefit, and so on. And your pupils might get dilated, they might, dry out, and that helps us see things at a distance better. So there's a variety of different effects of the sympathetic and parasympathetic nervous system. Now let's take a look at the areas of the brain that are involved in processing our emotions and generating our reactions to threat and to other emotional situations. So in this example in particular, we're going to be responding to a threatening sound. What we're going to talk about is something called the fear pathway. And this is a pathway in the brain that has been studied using a procedure called fear potentiated startle, as well as freezing. And fear potentiated startle is common in rats, but also in humans. We do it a lot. For example, if we're watching a scary movie and they have the scary music coming on and everybody's really tense, and then there is a loud bam and everybody jumps, right? You startle while you're watching that movie because of the tension that had built up. That is an example of fear potentiated startle. So you would normally startle to a loud sound, but you startle much more if there's this tension or fear that you're experiencing at the same time. And then in rats, they experience freezing. Humans also tend to do a little bit of this, but not quite, and not anywhere near as much as rats do. Freezing is just extreme immobility. They just freeze in place and stop moving. The reason is that predators like cats will not notice them as much. So a lot of predators' visual systems will use movement to help track a prey animal. And so if a prey animal like a rat or a squirrel or a rabbit is completely still and immobile, they're harder to see. So it's a way of sort of defending themselves. And humans show a little bit of a freezing response too, but again, humans don't tend to freeze as nearly as much as, say, a squirrel does if it's threatened. So let's take a look at these reactions to a threatening sound, okay? So maybe the sound of tires screeching as you're driving and you are worried you're going to get hit by a car, especially the case if you've already been in a car accident like that, or the threatening sound of a rattlesnake, or some other threatening sound, whatever it might be. So the sound first gets processed in the thalamus. In particular, this part of the thalamus called the medial geniculate nucleus, the MGN. And if you remember, that's involved in processing sound, right? M, medial, we can associate that with music. Now, here's where it gets interesting. The information leaves the thalamus and goes through two pathways. So it can go up to the auditory cortex, where we can consciously process the sound, but it can also go directly in a faster pathway directly to the amygdala, where the emotional significance of that sound gets processed. So if you have been in a car accident before, where you heard those screeching, tires, and then you were involved in a car accident and you got hit and shook around and scared, then the amygdala is going to very quickly assign to the sound an urgency. It's going to say, oh my gosh, this noise is a high level of emergency. And then it is going to do two things, and hence the two arrows. It's going to notify your hypothalamus so that your hypothalamus can generate this activity in the sympathetic nervous system. And that is going to do all of these things. It's going to make your palms a little sweaty, dilate the passages in your lungs, increase your heart rate, right? Supply the maximum amount of blood out to your muscles, and so on. And so it's going to do all of these things that the sympathetic nervous system does. In addition, the amygdala is also going to notify the midbrain PAG, the periaqueductal gray. And the PAG is involved in generating whatever behavioral responses you would make in this case. So I might grip the steering wheel to kind of hold on a little harder. I might push down on my own brakes to try and slam on my brakes. And so we can think of these behavioral responses, the gripping of the steering wheel, the stomping down on the brakes, and any other response I might make or an animal might make at that time as being the behavioral response. In animals, they have more behavioral responses than humans. They might attack an animal that's attacking them. They might hiss or make other loud noises to try and fend off the attack. They, in the case of squirrels, will throw dirt at a predator like a snake and sort of defend themselves that way, and they might even bite the snake, for example. So these responses are all determined by the periaqueductal gray here. And so with this circuit, what we have is a fast circuit that is capable of reacting to threat before your auditory cortex has a chance to really analyze it. And so it means that we can go from calm and relaxed to a very quick reaction generated by the amygdala, who recognizes the sound as something threatening, activates your sympathetic nervous system through the hypothalamus, so your heart is pounding in your chest and your palms are getting sweaty, and also activates your PAG so that you can engage in whatever actions you would engage in that situation. You might run, you might hide, you might fight, you might just curl up and try and protect yourself, whatever the behavioral response is going to be. And so this is the fear pathway, and it's, again, a fast pathway that prioritizes reactions to threat. Now, when we look at this pathway, we can see that it is also a pathway that can form associations, in other words, memories. And so if we think of a car accident where I hear the sound of brakes screeching and then bam, there's the impact of the car accident, that is capable of being connected as a memory, and partially because within the amygdala, we can see that the thalamus sends the information about the sound, and then the thalamus also is going to send information about what I feel physically when I get into the car accident. So maybe I'm shaken up, and maybe I hit myself and bruise myself. And so those two inputs, the sound of the screeching tires and the sensation of being kind of banged up inside the car, can get connected here inside of the amygdala. And then the amygdala goes out and turns on the hypothalamus and turns on the sympathetic nervous system that way, turns on the periaqueductal gray so that we can do our behavioral reactions, and also can produce relevant hormones like the stress hormones as well. And so really what I care about that you understand in this section is really just that the amygdala can connect or associate the sound of something with an unpleasant, feeling or reaction, like in the car accident.